Hello everyone, so welcome to this workshop on train your first natural language processing transformer model with Amazon Sage. And here we have Mark, McQuade and Philip. So before giving a bio about them, my name is Aishwarya Lada and I'll be the moderator for this session. And a small introduction about me is I'm currently working as a data scientist at Cisco. I'm a research graduate from the University of Waterloo with specialization in data science and machine learning. So to tell briefly about Philip, he's a machine learning engineer and tech lead at Hugging Face, where he leads the collaboration with Amazon SageMaker team. He is passionate about democratizing and productionizing cutting-edge NLP models and improving the ease of use for deep learning. And coming to Mark, he is AWS and cloud-based solution specialist. He's a knowledge addict and relationship builder. He's a machine learning success and business development lead at Hugging Face. So yeah, I will leave the stage on to Mark and Philip. We can get started. And guys, before the session starts, if you have any questions, please ask them in the chat with a Q in front so that our felicitators can identify them and they can answer the questions at the end of the session. So yeah.
Perfect. Thank you very much. So let me just see here. Everyone hopefully can see my screen. Everything's good. So hey, everyone, thanks for joining today's session on an intro to Hugging Face and a hands-on workshop with Hugging Face on Amazon Sage. So as I was introduced already, my name is Mark McQuade. I'm the ML Success and Business Development Lead here at Hugging Face. I am in Florida in the US, newly migrated actually. I'm actually Canadian from the Toronto area, but I am new to the US and to Florida. And there's my links for Twitter, LinkedIn, and my email if you need to get in touch. So joined with me today is Philipp Schmid, who is the ML engineer and tech lead here at Hugging Face. He's coming to us today from Germany, where it's pretty late in the evening, I guess, over there. You know, Philipp is the man, the myth, the legend when it comes to AWS and SageMaker with Hugging Face. I'm sure you probably, if you haven't, he does a ton of events and talks and workshops, you know, and he was, you know, one of the people that built the integration with SageMaker and Hugging Face. And as you can see, there's Philipp's contact information as well if you need to get in touch. All right, so today's agenda, you know, so it's, you know, mainly we're doing a workshop here, but I am going to run through a few things first. I'm going to introduce Hugging Face itself as a company. We're going to go through the Hugging Face ecosystem a bit, and then we'll go hands-on. We'll let Philipp take over and get into the fun. So before we begin, I'll start with a little guessing game, which may be pretty obvious to some of you, but the question here is, what is the common link from everything you see here on this slide, right? So Tesla Autopilot, Gmail autocomplete, Facebook translation, and Bing search, right? And the answer is the transformer model. So here is an architecture of the original transformer model from the Attention is All You Need paper. And through the transformer model, right, Tesla can make sense in what the camera sees in vector space. Gmail is able to predict how you want to finish your sentence. Facebook is able to automatically translate posts into over 150 different languages. And you can ask Bing a question in natural language, and it understands it, and it retrieves the information relevant for your spoken search. So another piece that, you know, about these, you know, 4 transformer use cases, which is less commonly spoken about, is that they each handle billions of predictions per day. So today, if you're not Google, if you're not Facebook, if you're not Microsoft or Tesla, there are rare cases where companies are able to use, train, and deploy transformer models at scale. And that's what our mission is at Hugging Face, right? It is to democratize NLP and transformers. Or should I say it was to democratize NLP. So we at Hugging Face want to make it the latest state-of-the-art, you know, science available to as many people as possible. So we are now, you know, our new mission statement is to democratize machine learning in general. So because transformers are literally eating the world of machine learning, you know, we introduced various transformer-based architectures for now speech and vision, right? So the traction of these new areas and tasks are amazing and growing with incredible speeds. So you're probably asking yourself, how could a small startup achieve something that Google and Microsoft are doing, right? So the answer is pretty simple. One part of it is our awesome and growing community. That's really the backbone of what we do is based on our community, right? So the Transformers library itself now has over 1,000 individual contributors, right? And if you can see on the right side there, the GitHub stars growth, right, over time. Now in red is the Transformers library, right? And as you can see the growth, it's unbelievable, right? It's up next against, in the graph here with other open source projects such as Mongo, right, or Spark, right? So you can see what the Hugging Face Transformers library is doing and the growth with that library. So in addition to this, we have over 20,000 publicly available community models in over 200 languages on our Model Hub. And in a few slides, I'll get into exactly what the Model Hub is. So this is just a list of some of our clients today, right? Some of them using it in research or in production, right? And it's just some big names, right? As you can see, right? For research purposes, Google, Amazon, Samsung, Facebook. From production, you're looking at Bing, right? Chegg, Cloudera, Bloomberg, and Apple as well, right? So it's used by over 5,000 companies, all the way from research to production. So another thing I wanted to highlight is our Hugging Face course, right? So earlier this year, we launched the first part of our own, fast AI type course, fast AI light type course. This course will teach you, all about NLP using transformers and all the open source libraries, and it's completely free, which is obviously a big bonus. And you can find it at huggingface.co/course. And you could, do the course in PyTorch or TensorFlow. There's 2 different variants. And it's also worth noting the part 2 of the course was actually launched today. We have a whole community event week going on around part 2 of the course. So please do check it out. It is a fantastic resource. So as I mentioned, right, there's over 5,000 companies using transformers in production. Here are just a few examples of how companies are using transformers. It's always good to see the specific use case and line them up. So for example, Monzo is using text classification to accelerate their customer support, or Chegg is using transformers to extract and retrieve information, right? And these are use cases, but how are you able to implement them yourself or bring them into your own company or project? And that is enter the Hugging Face ecosystem. That's where the Hugging Face ecosystem comes in. Okay, so as you can see on this slide, right, this is the Hugging Face ecosystem, right? This is the overview of it, right? So it's grew really, it's grew much more over the past, X amount of months, right? We went from just providing models, right, and now to a full end-to-end machine learning platform with open source and open science as the building blocks. And the heart of the ecosystem is the Hugging Face Hub, okay? So I'll get into that a little bit more now. So the Hugging Face Hub has 2 pillars, all right? It has the Model Hub and the Dataset Hub. So the Model Hub itself is a central repository for state-of-the-art models across different frameworks, right? So as I mentioned before, the Model Hub currently hosts, it's over 20,000 public models right now from the Transformers library, but also from other NLP libraries, right? Like Allen NLP or Flare. The hub also has models from vision libraries now, like TIM, and speech libraries like SpeechBrain or ESPNNet, and others as well. So some of the newest additions actually as well are scikit-learn models as well as fast AI. And now looking at the second pillar is the Dataset Hub, right? So what is the Dataset Hub? It offers over 5,000 available datasets in the Dataset Hub. And these are datasets that range from NLP, vision, speech, tabular, and many more. So you can use the Dataset Hub to host your own datasets, public or private, and then load them without writing any code inside the datasets library. Now we're going to look at the open source piece of the ecosystem, which is the transformers and tokenizers. So tokenizers and transformers are really the building block of modern NLP, right? Tokenizers can be used to convert text to tokens and then to IDs, and that is then used in transformers for training and inference. Transformers currently contain 74 state-of-the-art transformer architectures for NLP, vision, and speech. Now, the Transformers library also provides a trainer API to easily let you fine-tune a pre-trained model on a given task and a given data set. So it also supports distributed setups, right? CPU, GPU, multi-GPU with multiple nodes or one node, as well as TPU. Okay, now we look at the ecosystem overview of the managed training solutions. So for our managed training solutions, first we have on the left there AutoNLP, which is an AutoML library for NLP, right? So AutoNLP is good for speech and vision as well now, as you can see a common trend, as I keep saying, it's not just natural language processing anymore. So with AutoNLP, you can train state-of-the-art transformer models without any experience or knowledge. You just need to provide your data and we will handle the rest. You could think of AutoNLP, if anyone is familiar with the AWS ecosystem, as like comprehend on steroids type thing. And then as you see on the right, we have SageMaker. With SageMaker, you can reduce the heavy lift from the infrastructure side, right? Don't worry about your managing infra when performing deep learning, and you can concentrate on the important things such as training your model, right? That's the main thing. SageMaker takes care of the rest, right? It starts and stops your instances and such like that, and just manages the whole infra piece. So now looking at spaces. So after you've trained your model using the open source, or it could be AutoNLP or SageMaker, you probably want to test this before going into production, right? And that's where spaces can shine. So spaces are a simple way to host an ML demo app, right? Directly on the huggingface.co website. So we support two awesome SDKs that let you build cool apps in Python. It's Streamlit and Gradio, right? So this is actually fairly new. Spaces came out, fairly recently. We pushed this out, and I highly recommend trying it out. It's a fast and simple way to get a simple web app going for your ML project. Now to the last piece here of the ecosystem I'm going to talk about, right? After you have a model trained and you have it tested, you want to use it, right? And that's where our inference solutions come into play. So on the left here, you have our Inference API, right? So the Inference API hosts any of the 20,000 plus models from the hub with an option of acceleration. So if your model is available on the hub and it is automatically deployed to the Inference API and ready to use for inference from within our application, right? So we completely abstract all the knowledge required for deploying and scaling that. And then on the right, we have the SageMaker piece, right? So the SageMaker integration, you can also host these models, the same models, but inside your own environment, right? It's controlled by you. So if your company has, compliance guidelines or anything like that, you can easily manage them. So additionally, SageMaker allows you to extend the inference code. So if you have some custom pre-processing you need done, you can define this when using SageMaker. And last but not least is Hugging Face Infinity. So Hugging Face is another very new product for us. It was launched end of September. Infinity is a containerized solution to deploy fully optimized inference pipelines for state-of-the-art transformer models in your own production environment, right? So we're able to achieve 1 millisecond latency for BERT-like models on GPU and 4 to 10 millisecond latency on CPU. And I'll let Philipp probably speak to that after, but I think he's actually, we're actively working on this, and I think he's actually improved on that CPU number. So yeah, it's a fantastic product that you should for sure check out to improve your latency. And something else I want to touch on is our premium support offering, right? So what is premium support? It is what it is, it's support. So it's the ability to get direct access to Hugging Face experts to support, advise, consult on any of your existing ongoing projects, right? It's seat-based pricing along with yearly commits, just to mention that. And what's the big deal with Hugging Face support, right? How does it differ from other, support offerings? Well, it's our experts, right? So you get access to the best worldwide experts in transformer models, right? So just to go through a few, Thomas Wolfe was the creator of Transformers. So, he's with Hugging Face, of course, he's one of the co-founders, right? So Colin is the first author of T5 from Google. Morgan is a contributor to the ONX library. Julian Simon, who as well has came over to Hugging Face from AWS, where he was a global ML evangelist and author as well. Abhishek is a worldwide expert on AutoML. Victor is the author of DistillBERT. Sasha Rush is a professor at Cornell, and Anthony is the creator of the tokenizers, right? So as you can see, this is what kind of sets us apart is, all these experts that are in-house within Hugging Face that are able to help you out and answer any of the questions that you may have as you go down your path to project. And certifications, that's another thing that's ongoing. We're actually we're just creating this now, right? It's providing Hugging Face certifications, right? So you can provide your team with the necessary training and course to be proficient on Hugging Face and Transformer models, right? So how does this kind of differ from the free course? Well, we were able to customize this, right? Customize the training to your specific tasks, your specific models, and your needs, right? And we also provide standardized testing through this, right? So your team could get certified, and you can be confident that your team is fully skilled in the world of transformers to tackle all your future projects. And with that, I'm going to get into the fun. I crammed a lot into a little bit of time there, but I know we want to get into the hands-on as this is a workshop format. So I will hand it over to Philipp.
Perfect. So yeah, hey, and welcome from my side as well. I hope Mark is not frozen anymore, maybe. Yeah, if you have like any questions, like feel free to ask them like immediately. We have like a few sections where we can answer those or can go into detail a bit more about what we are doing. And you should see like my notebook I'm currently opening. It has a few more links in the beginning to where you can find resources about Hugging Face transformers using SageMaker. I will share it like in a minute in the chat. It's available on GitHub, so you can like either already search for it for TMLS SageMaker Hugging Face workshop, or I will share the link with you any minute. And what we are going to do today is basically fine-tuning a multi-class classification model using the trainer API from our PyTorch flavor transformers library with the emotion data set, which is a sentiment data set consisting out of 6 different labels from tweets. And we are going to use this to bird, and of course, like Amazon SageMaker is our main training platform. And then afterwards, we are going to deploy it directly to SageMaker to run our inference. So here you can see like it's the widget of our Hugging Face hub. So you can like test the model or test the data set already. And what's going to do is basically you provide a sentence, and then it's going to predict afterwards, okay, which emotion the sentence represents. And then to get started, so I'm going to use Amazon SageMaker Notebook instance, which is like a managed Jupyter version provided by AWS. The benefit of it is that I can use the get execution role, which basically gives me all the permissions I need to run my training immediately. That you can like also easily use the SageMaker Studio or use like your local machine. The only difference is then that you need to provide your own IAM role basically to get like all the permissions you need to start your training job then. Of course, the first step is we want to install the latest SageMaker SDK. We want to install Transformers version, and then due to compatibility issues, we make sure we install the datasets version 1.13. And then afterwards, we just want to make sure that the Hugging Face part of the SageMaker SDK is available, and it is. So we are good and ready to go. And after you have like your environment set up, you of course want to make sure that you have all the required permissions available. So what we need is basically we need permission to start our SageMaker training job. We need permissions to an S3 bucket, and we need permission to basically start all of the underlying infrastructure. And all of this is nicely provided by the SageMaker SDK and the get execution role, which basically get us all the information we need. And at the end, it prints out, okay, we are going to use this IAM role, which has the permissions we need. We are going to use this bucket. In this case, it's created by the SageMaker SDK automatically. If you, for example, have like already a dedicated bucket for your experiments or where your data set is included, you can easily define the variable here, and then SageMaker will use your dedicated bucket, and then we can see the region where we are running in. Okay. Next step, before running training in NLP, you always need to pre-process your data set. And in this case, since we are running our training on a GPU, we want to make sure that our data set is pre-processed in advance, since pre-processing always use CPU. So we want to get like basically the best out of both worlds using the CPU provided by our managed SageMaker notebook, and then use the GPU to run our training. And what we are going to do is we are going to use this bird model the emotion data set, and then we are just defining basically a location on S3 where we want to store our data set. And then it's basically a simple pre-processing step using transformers. So we load our tokenizer, we write a small little helper function which tokenizes our data set. We make sure that we pad it to the max length basically, so that we avoid any inconsistency. We make sure that longer sequences are truncated. Then we load the data set, run the tokenization against it, and then apply PyTorch specific conversion so that the underlying data set already contains our tensors and not like Python dictionaries. And then I think what's really nice about the integration is that in the datasets library, you have something called S3 file system, which allows you to basically directly upload your dataset from in-memory to S3. So the only thing we need to do, we have our train dataset, which is tokenized, transformed, put into the right format for our training later. We can save to disk, and we provide our S3 file system. Then we have our session bucket, we have our prefix, and then the datasets library will take care of everything behind the scenes. And now our dataset is uploaded to S3, which is like super awesome. And then when you have your environment set up, when you have all permissions you need, when you have your dataset pre-processed, you want to train. And SageMaker or the SageMaker SDK provides something called estimator. An estimator is basically your agent, your organizer to create your training jobs and to run your training. And we created a Hugging Face estimator, which basically holds all the information for your managed training. So it always has an entry point, which is the Python fine-tuning script. We have like a dedicated location where it is. We can give it a name. We can define, okay, on which instance we want to run, on how many instances we want to run. So we can easily use the same script we use for running fine-tuning on a single machine, for distributed training on multiple GPU or even on multiple nodes. Then we define which transformers we want to use, which PyTorch version, which Python version. Then again, we need to provide our IAM role to basically load the data set from S3 and run everything we need. And then we, of course, need our hyperparameters, which will be when starting the training past SCLI arguments. But we will take a second at the training script. So just printing out a training script, we take a look at in a minute after we started the training. And then for our training job, we are going to run on one epoch. We have a train batch size from 32, a bigger eval size, since the eval data set is a bit smaller. We define the learning rate. We have again our distal bird model, and we want to use mixed precision, so our training is a bit faster. And then here you can see the Hugging Face estimator we are going to use. We have our transformers version with 4.10, the same as we have installed. We have our job. We are using a P3, which has a nice NVIDIA GPU under the hood. So we can create it. And then basically everything you need to do to start your training is to run execute.fit method. And to do this, we are also providing our data set. So the train input path basically contains our S3 URI where we have uploaded our data set. And the test input path it contains the test data set. And now we can execute our training, and SageMaker will take care behind the scenes of loading our data set from S3, starting the correct container based on our transformers version, our PyTorch version, start a correct instance type, and then starts our training using our train.py script. And what's really cool about it is that our train.py script is not located somewhere in the cloud. It's located inside of this notebook. Okay, so it won't execute since our training runs, but I can show you in a second. So I already printed out a training script, which is located in scripts train.py. So it's inside a notebook, so you can like easily work on it, try things out, experiment, executing it using your notebook environment. And then when you think you're ready, you can start your managed training by just creating the estimator and then running your .fit method. Okay, the training script is like a normal Python script, you know, from basically any Python script you already wrote. In the beginning, we have an args parser so that the hyperparameters we passed in are like converted into a nice namespace and then can be used. It's nothing special about it. So you can either define all the potential hyperparameter you need, or if you don't want to use any hyperparameter at all, you can directly hardcode them into your training set. We have the ones we defined with our epoch, the batch sizes, then the learning weight we want to use, mixed precision. And in addition to this, we have some, basically default environment parameter and args arguments, which are provided by SageMaker. So to basically get your model out of your training job after the training is done, or to save your logs, or to do special things with GPUs, SageMaker always provides environment variables, which you can, like for easier use, I pass them into the arguments, but you can also directly use the environment variables. So for example, the SM channel train and SM channel test are the location of our dataset, which was loaded from S3 onto our training machine. So we can access them later to load our dataset again. And the SM model dir is basically the environment variable to the path where we need to save our model to upload it after our training to S3 again. And then as first, we are setting up our logging, and then we can like immediately load our pre-processed data set, which uses the args training dir, which again correspond to the from SageMaker provided channel where the data set is stored. We print it out to make sure that like everything is fine. We load our metrics. In this case, we are going to use the load metric function from the datasets, which already has a lot of like built-in metrics. And we are going to use the accuracy metrics. We have an additional compute metric function to, basically makes it easier to calculate our results. And then what's very cool about this training script, so normally when you would run your training on a normal data set, you need to make sure that your labels are understandable for the model. So you cannot use strings. And what's nice about transformers is that each model has a config.json file, which if it's trained on sequence classification, contains a label to ID attribute and ID to label attribute, which basically maps our index of our label to a string, which we humans can read and understand easier. And what we are doing here is loading the features from our data set and creating those label to ID and ID to label configurations so that we immediately can apply those to our model after it's trained. So we have those nice labels when we deploy the model, instead of having like label 0, label 1, which is not very like, understandable for us. After we mapped our labels, we are loading our dataset using the auto model class. We have our model ID, which is the digital bird model. We define the number of labels, which is also extracted of our dataset, and then map our label to ID and ID to label, load our tokenizer. And then for you who have used transformers before, I expect you already have used the training arguments and the trainer. For those who haven't used transformers yet, it's pretty similar to what you get provided by Keras. So the trainer is basically our brain of running the training, where we provide our model. We have our training args, like those are the hyperparameters we are going to use. We provide our metrics function, and then the training and data set, training and test data set. And then we can run the .train method. And this training script also includes a conditional step to check, okay, maybe I have already run some fine tuning on my model and provided already like checkpoints for those. Then the script would automatically pick up the checkpoints and continue the training instead of retraining. And then we are just evaluating after we trained it, saving the results to an additional text file. And at the end, we are saving our model with our tokenizer, with our configuration of the nice mapping from label to ID and ID to label into our SageMaker model dir, which is then uploaded to S3 and can be used for inference running. Okay, so far what happened in our training is that SageMaker basically started the instance behind the scenes, downloaded the training data we uploaded before to S3, and then downloaded the training image. And the training image is also called a DLC, which stands for deep learning container. And a deep learning container basically is an optimized environment for a specific framework to run training on AWS. And before we started the collaboration with Amazon, there were already DLCs for TensorFlow, PyTorch, and MXNet. And with our collaboration, we created those DLC for the Hugging Face open source libraries to basically create perfect out-of-the-box solution you can use for training and deploying your Hugging Face transformers inside of the AWS ecosystem. Any questions so far? Okay, Mehdi asked, how does the tokenizer work for IT text data with so many unique and rare symbols, meaningless words? So each tokenizer has basically a vocabulary, something which is a normal dictionary to us humans. And those dictionaries can be extended to your domain-specific language. So for example, there are transformer models which are trained on programming code. So they learn like the syntax of Python and Java and then have like different tokens inside of their vocabulary than normal like English models. So it's you can like customize the vocabulary, and normally your vocabulary has around 50 to 60,000 different tokens. But if the tokenizer still runs into like unknown tokens, there's like a special token, like the unknown token, which then will be used for those words which cannot be identified. And normally, if you are like using an existing tokenizer for those kind of environments, you are either achieving good results because the unknown words are meaningless for the context. And if you are not achieving good result, it would be definitely beneficial for you to like either extend your tokenized vocabulary or maybe pre-train the language model on your domain-specific language. And then another question, do you guys use batch transform for training / inference in AWS SageMaker? How do you scale training? So batch transform is not used for training since it's basically a part of the inference service. We have notebooks available for how to use batch transform with SageMaker and also for inference. Maybe Mark, you can share those. It's like the Hugging Face notebook GitHub repository. And how do you scale training and inference? So scaling training is pretty easy. You can like easily replace the P3 instance, for example, with the P3DN 24x large, which contains 8 GPUs. And then since you have 8 GPUs, you, I guess, want to use distributed training. And then there's like a distribution parameter you can apply. And then it's like just a configuration for data parallelism. And then SageMaker would automatically start your training script on those 8 nodes. In addition to data parallelism, there's also model parallelism, where you need to provide a configuration for model parallelism. And then if you think, okay, those 8 GPUs are not enough for me, I want to go with 16, then you can easily scale up the instance count. And as far as I know, you can go up to 32 instances, which would mean you have like almost 260 GPUs running, which should be enough for like most of your training jobs. And then for inference, I could also share resources for a workshop we have done 3 weeks ago, where we really went into detail on how to scale training. And it's pretty easy, I have to say. So SageMaker is completely managed also for inference, and the scaling of the endpoints works with auto-scaling groups. So auto-scaling groups are a nice, easy way to scale your instances behind the scenes. And the only thing, for example, you would need to define is, okay, how many requests per minute can my endpoint handle? So if I have my distribute endpoint for my text classification example, I know it can handle around 1,000 requests per minute. And then I could create an auto-scaling group. Okay, if those endpoints get more than 1,000 requests per minute, please scale up. And then I can define the min or the max range. So I can say, okay, scale up to 5 instances or 50 or 500. And then it will also automatically scale down again if like the request load goes down as well. Okay, is the notebook you're working on hosted on AWS? Who else would be? Yeah, so the notebook currently I'm using is hosted on AWS using the Amazon SageMaker notebook instances. But of course, you can like run the exact same notebook from your local machine. The only difference you need to be aware of that is when you import SageMaker or the Python SageMaker SDK, the method getExecutionRole won't be available on your local machine. So instead, you need to use Boto3 and provide the IAM role. But if you check out the documentation, so we have like a dedicated documentation for how to use Hugging Face transformers on AWS. And if you go into the run training on Amazon SageMaker section, there's an install and set up your training environment where this is documented. So here you have the steps, what you need to do when running on AWS. And here are the steps for your local environment. So the difference is that you would use Boto3 and the IAM client. And here you would need to provide the role name of an IAM role, which has permission for SageMaker. Okay, going back to our notebook since our training job is done. Okay, what happened during training is SageMaker basically puts out a lot of logs. In the beginning, we get all information about the environment where we can see our hyperparameters, the number of CPUs, the number of GPUs, the environment variables set by SageMaker. And then what's nice about it is basically it streams the std out from your Python script running on your remote machine to our notebook. So here we can see a log from our training job, which in this case printed out the loss, the learning rate, and the epoch. So it's training information. And we can also see the evaluation from the trainer.evaluate, which we run with our matrices. And that everything is saved. And then if we scroll down again, we can see, okay, everything has saved. The model took 574 seconds to complete. And now we can deploy. And to deploy, we basically need to run the .deploy method, and that's it. And now SageMaker will use our model, which we have fine-tuned on S3, and deploy it to SageMaker again, but to the Inference service to run predictions. And in this case, it's similar to the estimator, but it's way easier or what we need to provide. So the 1 here stands for the instance count, and the ML G4DX large is our instance type we are going to use, which is also an instance with an NVIDIA GPU. And maybe to like go again into detail on how the SageMaker platform itself works. So we are here at the top right corner. We are the data scientists. We are the machine learning engineer using the SageMaker SDK. And in addition to this, there are those Hugging Face DLCs, one for training and one for inference, which are also open source and available for the community. And what we are now, or what we have done in the beginning, is we defined our estimator with our predefined Hugging Face hub model. And we uploaded our data set to S3, which was pre-processed, tokenized, so we can use it for training. And then when we call our estimator.fit method, the SageMaker platform will use the Hugging Face hub to load our pre-trained model, load our data set from S3, and then runs our training on managed instances from SageMaker using our Hugging Face training container. And after the training is done, SageMaker will save basically everything we have saved into the SM model deal to S3 again, which in our case was our tokenizer, our fine-tuned transformer model, the evaluation results, and everything we have saved to the directory. And afterwards, with the .deploy method, we can directly deploy the model from S3 to SageMaker for model inference. And SageMaker Inference provides like a model service. We have automatically, we have auto scaling with the auto scaling groups, which we can easily configure. And then it exposes an endpoint which can be used by our applications, by other services, or directly by users. And everything is managed by SageMaker. And that's super awesome because you are not paying for instances because, I mean, you are paying for instances, but you are not like need to watch out if an instance still runs training, or if you already can shut it down. So SageMaker starts the instance, runs the training, and then stops the instance. So you are like 100% efficient in terms of your usage. Okay. Okay, and another question. Can we say that if my data has tokens that the pre-trained transformer model such as BERT hasn't seen them, the model will not perform well, especially if those tokens are important for the task at hand, right? Yeah, so like expecting you're using the default BERT base model, which was fine-tuned on the pre-trained, on the Wikipedia data set. It knows a lot of like common English language. And then if you want to fine-tune it on chemistry or biology with a lot of like foreign special words in it, it's mostly going to either unknown those tokens, or it's just since it never has seen those words, how can it know what those mean? So I guess if you have like a really domain specific corpus you want to work with, I would definitely suggest you to try those already pre-trained models to fine-tune them on a given task. And if they don't perform well, then definitely further pre-training on your domain specific corpus can improve performance. But it's pretty interesting that even the model might not have seen the word that frequently, it's like already creating good results on it. Okay, since our model is still deploying, which should take maybe 1 or 2 more minutes, I can show you a few more additional resources. So we have already seen the documentation, and Mark should have shared the notebook, which I'm currently running, I think. And then we have more notebook examples. So on Hugging Face, we have a dedicated repository called Notebooks, which has a dedicated section to SageMaker. And currently we have 14 different notebook examples for getting started with PyTorch. That's pretty similar to what we have run. We have examples for TensorFlow, which is basically a replication of the training we did, but using TensorFlow. Then we have examples for data and model parallelism. And then we have like also examples for, okay, how can I work with inference? And there's, for example, a dedicated notebook on how to deploy and auto scale my transformer model for inference. Okay, notebook is done. So our model has deployed, and what's super nice, so the Hugging Face estimator in the beginning was the class created to run the .fit method, and this basically returns an object where we can then run the .deploy method, since the Hugging Face estimator class knows about the artifact we have trained. And the .deploy method returns a predictor object, which we can use to run our prediction. And the inference API we have built around for SageMaker is pretty similar to what you already know from the hosted inference API. So you provide a JSON with an inputs key, and then with your string to it. And in this case, I get nervous before a demo, and our model predicted, okay, maybe I'm feared with a score of 95%. But similar to this, I can easily change it to, I'm super happy with the results of my model, and then can run predicted or predict again, and it correctly predicts, okay, I'm joyful, I'm happy with the results of it. And then SageMaker SDK also provides a nice like cleanup function to make sure, okay, we have tested our model, but maybe I don't want to use it yet. Maybe I need to like check a few other things and want to deploy it later. Maybe let's delete our endpoint for now, and then I can run predictor.delete endpoint, which basically cleans up the whole infrastructure behind the scenes again. And we are making sure that we are not wasting compute time. So no, Hugging Face does not only work on SageMaker. So you can basically use the Transformers tokenizer library, Optimum, Accelerate wherever you want. I think the only difference for using it with SageMaker is that you don't need to worry about managing your infrastructure. So training and deploying transformers model is not as easy as people think, since you have like model which are between a few hundred megabytes up to few gigabytes basically, and you mostly need GPUs to run the training on it, and you mostly need large CPUs if you want to run training on big data set. And this is everything what SageMaker abstracts from you. So as you have seen, we have this nice little Hugging Face class inside of SageMaker, where we basically describe what we want to do or where we want to do. We have our Python training script, which is can be run anywhere. So you can run it on your local machine just to test, okay, does my training work? Do I have any syntax error in it? And if I know it works, I can easily scale up my training using SageMaker and the Hugging Face DLCs for it. Camilo, there's, yeah, I've seen. So Camilo asked, is there documentation on converting notebooks/scripts to SageMaker pipeline? So maybe for those of you who don't know, SageMaker pipeline is a service which got introduced last year at reInvent by AWS, and is a, yeah, basically it's a CI/CD service for SageMaker to create end-to-end pipelines for running your training or running evaluation, where you can have like a dedicated step for pre-processing. So what we have done in our notebook at the top, where we pre-processed our data set, you can like exclude those steps into a dedicated step running on SageMaker processing. Then you could have like your SageMaker training step the same way as we had. And then you could have like a conditional step checking, okay, how was our evaluation? Do we want to deploy it? And if our evaluation or our accuracy is above 90%, then we want to deploy. And with SageMaker pipeline, you can basically describe your machine learning pipeline from pre-processing until production or deployment. And we had a workshop on this last week, and the code for it is still available, and the recording is also on YouTube. I think, yeah, Mark just shared the YouTube link to it, and I shared the code to it. And yeah, the notebook, it's also, again, a Jupyter notebook with all of the steps you need to go through to create your own SageMaker pipeline for creating those end-to-end jobs with conditionals to make sure that only you deploy good models into production. Yeah, I think I can check again, but I need to deploy the endpoint. So we need to wait a few more minutes, and then we can check on a negated sentence, Kirchner. Yeah, right. So the distal bird model we used was pre-trained on a large corpus. So for the distal bird model, it's a bit different because it's a distilled version of the bird model. But for example, the bird model or the bird-based model was pre-trained on a large Wikipedia corpus and a book corpus using the masked language modeling task, which basically means it's an unsupervised task. You have your model architecture, you have your large text corpus, and with masked language modeling, you're replacing a few words with the mask token, and then the model the models is going to learn, okay, which token is missing or which token was masked. And then for the bird case, it was also pre-trained on an additional task, the next sentence prediction, where you had as input 2 sentences, and bird needed to predict, okay, is the second sentence the next sentence or potential next sentence of the first sentence. And then those models have been uploaded or provided to the community. You can find them on the Hugging Face Hub. And what we have done is we used those pre-trained weights to fine-tune it on our sentiment data set for the emotion data set. So we are basically making use of all of the knowledge which the model gained through training on those large book corpus and Wikipedia corpus. Yeah, and definitely for those of you who are maybe not that experienced with transformers, you should definitely check out the Hugging Face course. Mark has already plugged it in the beginning, I think. You can find it on huggingface.co/course. And then currently it's chapter 1, where you learn everything about the different transformer architectures. So there are encoder models like the bird we have used. there are decoder models, GPT, you probably have heard of, and there are also like sequence-to-sequence models, which get text in and put text out for summarization tasks. And there you learn everything on how to use transformers, what are transformers, how I can fine-tune my model, how I can fine-tune it on the different tasks. And it's, as Mark said, completely available in PyTorch and TensorFlow, and you can run it inside of a Google Colab, so it can be run completely for free. I already copied the example Kirschner wanted to test. I think definitely something we should be aware of. The training only run for one epoch, so it's probably not the best we could get out of it. But let's see what the model predicts. And Chiuna, yeah, definitely. So he asked, or she asked, is it scalable for high volume streaming? An example, 10 million requests per day. So yeah, of course. So what SageMaker basically does or provides is the automatic auto scaling. So if you know how many requests your model for your specific instance type can handle, so for our use case, we have the G4 DNX Large, which has a T4 NVIDIA GPU in it. We have a DistilBERT model, so each inference should take around maybe 20 to 50 milliseconds. So we could calculate up our load and know, okay, our model or our instance in this case could handle maybe 1,000 or 2,000 requests per minute. And then I can easily calculate which or how many instances I would need. Or I can go with the auto scaling part of it, where I say, okay, at minimum, I want to run 2 nodes or 2 instances, so I can always handle like 4,000 requests per minute. And the maximum, I want to have 14 instances, and I want to scale up when I get like more than 2,000 requests per minute. And then SageMaker will automatically scale out and also automatically scale in if the load drops or increases. So it's like totally scalable for any kind of workload. You just need to make sure that you know which load you're going to expect, or that you have like the correct auto scaling parameter defined. Okay, the model is deployed and we are going to use the example. And I guess in this case, I am not super happy with the results of my model. Was represented with joy, but I guess it's not correct. Maybe we can adjust it a bit more. I'm not super happy. Maybe I'm not happy. And it still predicts joy. Yeah, I guess it's a perfect example that we definitely need to further fine-tune our model, since it would identify, I guess, maybe my results aren't good. Okay. Yeah, so you definitely need to run more fine-tuning on this than just a one epoch. I mean, normally you should see good performance after 3-4 epochs for the models. And if you check out the Hugging Face Hub, so I mean, we have still a few more minutes, we can go to models. And since it's the emotion data set, which is pretty common, there are all like 280 different models which include the emotion in the name. And this is also a DistilBERT-based uncased model fine-tuned on the emotion data set, and it achieves 93% accuracy, which is pretty good, I would say, on a test data set. Yeah, and that's the Hugging Face Hub and how you can use Amazon SageMaker for training. Any last questions? Mark, do you have any last words? Anything you want to share with our participator?
No, I appreciate everyone for joining us today and taking the time. And feel free, as I said, to reach out to myself or Philip or about anything that you need. And I mean, as Philip said, go through, tons of notebooks and stuff. If you're looking for specific around SageMaker, there's tons of stuff. I also linked to the 3-part workshop series that Philip just wrapped up, which kind of goes end to end, right? From taking this, what he showed as one example and going, right through and fine tuning and deploying, and MLOps with SageMaker pipelines. So yeah, feel free to check that out. It's a great resource, and check out the course, as I said, to learn more about transformers in general.
All right. Thank you very much, Mark, and thank you, Philip, for the wonderful session and enlightening everyone. And yeah, thanks everyone for joining. Have a good rest of the day.